Welcome my dear students. Today we will discuss about the continuation part of chemical kinetics. So in the last class we have discussed about the order of the reaction. No doubt order of the reaction they are expressed in terms of rate of the reaction. The similar concept of order of reaction is molecularity. In the molecularity concept we are discussing about the based on reaction we are writing the what is molecularity of the reaction. So look here, molecularity of an elementary single step reaction is the number of species. Species are nothing but atoms, ions, molecules, anything. They must collide simultaneously for the reaction to occur. Means if the 2 or 3 reactants are present in the reaction, they should ready to react with each other at the same time. Means simultaneously they have to react, so that the number of reactants, how many moles are there, that itself is called as the molecularity. So molecularity is nothing but the sum of number of moles of reactant is called as molecularity. For example, we will come to know that a reaction containing only one mole, means only one reactant are there. How many moles of that reactant is there? That number of moles in the reactant is called as molecularity. The definition is very simple. When we move to the examples, we will understand it still better. It means the number of moles in the reactant is only one, then we are calling that as unimolecule. The number of moles of reactants are 2, then we are calling that as bimolecular. Similarly, if the number of moles of reactant are 3, then we are calling that as turbomolecular reactions. So these are the 3 kinds of types of molecularity. So we will look at the examples of each one. Look here, the decomposition of ammonium nitrate, which gives nitrogen and water molecules. It is an example for unimolecular reaction. Unimolecular reaction, how we are writing, on what basis we are writing this? Just to look at, in this reaction the number of moles in the reactant is ammonium nitrate. Just to look here, the number of moles in the reactant, that ammonium nitrate is only 1. Therefore, 1 mole of ammonium nitrate is undergo the decomposition to give 1 mole of nitrogen and 2 mole of product. Look here, you are not supposed to forget that here we are giving the preference for definition of molecularity based on number of moles of the reactant. We are not discussing, we are not looking at the product, how many moles of product are formed, we are not bothered about that one. Means the molecularity is giving that the number of moles of reactant are present in the reactant. Based on that we are defining. Unimolecular reaction is nothing but here number of moles of reactant is only 1. Therefore, this is an example for unimolecular reaction. Don't forget, you are not supposed to look at the product, just look at the reactant. And the second one is, that is bimolecular reaction. The decomposition of hydrogen iodide Hi is going to give a bimolecular reactions. Means Hi undergo the decomposition to give hydrogen and iodine. The number of moles of reactant, here reactant is only 1, that is hydrogen iodide. The moles of reactant Hi is 2. Can you see it is here 1 mole, therefore it is unimolecular. The reactant here it is 1, but number of moles of reactant are 2. Hi is 2 molecule of hydrogen iodide is undergo the decomposition to give hydrogen and iodine. So here number of moles of reactant is 2. Therefore 2 Hi is there, 2 molecules in the reactant is there. Therefore this is a bimolecular reactions. Similarly, in a turbomolecular reactions, here the formation of NO2 is formed from the NO. You just make it as capital NO, nitric oxide. 2 moles of nitric oxide reacts with the 1 mole of oxygen, O2, which is a gaseous molecule, that's we have written as O2. But the number of molecules of O2 is 1, single it is. 2 molecules of nitric oxide reacts with 1 molecule of oxygen to give 2 molecules of nitrogen dioxide. I said you are not supposed to look at the product, just look at the reactant. Here reactants are 2, one is nitric oxide, another one is oxygen. In the nitric oxide it is 2 molecules. Therefore 2 molecules of 1 compound means 1 reactant, another one is O2 is 1 molecule. Therefore together it is 2 plus 1. There are 3 molecules of reactants are present in this reaction. Therefore it is example for turbomolecular reaction. Once again I will explain it. Uni is nothing but the number of moles of reactant should be 1. If the number of moles of reactants are 2, then it's called as bimolecular. If it is 3, then we are calling that as turbomolecular reaction. I hope you understood this concept clearly. If you feel it is little bit fast, please once again watch this video by pausing or repeating. And we will move to the next one. Here the molecularity is probably 1, 2 and 3, but it not more than 4 and 5. Means it is cannot be a reaction have a molecularity 4 or 5. Means even though it seems like a 4 or 5, but it is not actually the molecularity of that reaction. Means we are writing that molecularity on the basis of single elementary steps. Means we are looking at the mechanism. Just look here, 4 moles of hydrogen bromide is reacts with the 1 mole of oxygen and it's giving bromine and water. The number of moles of reactant in this reaction, can you see reactants are 2. In this reactant, the number of moles are 4 and O2 is having the number of moles 1. Together 4 plus 1 is 5. Molecularity of this reaction is seems to be a 5, but actually it is not 5. How means? We know that the molecularity is never exceeds 4 or 5, or it never reaches 4 and 5. If it is seems to be like that, we are going that elementary reaction. Means we are looking at the mechanism of this reaction. In that mechanism, which step is having the slowest step, that step's molecularity is considered as the number of moles. Same as it is, we are considering the halo alkanes and haloarenes. We are considering the SN1 mechanism. It's containing 2 steps. In that, the slow step is considered as a rate determining step. Similarly, here also, just to look here, this reaction is undergo the mechanism. In that, HBr initially combines with O2, it gives rise to OBr. This the first step is a slow step, whereas second is fast step, and third one is also fast step. Here, it's undergo the 3-step mechanism. Overall reaction is again same, 4Br plus O2, 4Br plus O2, it gives 2Br2 plus 2H2O. Here, I hope you remember it, we are cancelling the HOBr and the H2OBr, these all things. But mainly, what we have to observe here is, in this mechanism, the first step, it is a slow step, and the slow step we are calling that as rate determining step. Obviously, you know this one. And the overall reaction, the step which is having the slow step, it is called as a rate determining step. And obviously, the rate determining step is also considered as the order of the reaction. What is the order of the reaction? Can be determined by the slow step only. And moreover, here molecularity is 2 in the slow step. Why? Because HBr, 1 mole of hydrogen bromide, is reacting with the 1 mole of oxygen. The number of moles of the reactant in the slow step is 2. Therefore, the molecularity is also 2 in the overall reaction of 4Br plus O2, which gives bromine and water. Are you getting my point? And I have mentioned here the order of the slowest step is also 2, but you should not forget that order of the reaction is not written based on the reaction. It can be written only by the rate expression formula. Rate is equal to dr by dt, means concentration of the reactant and power. The power sum is called as order of the reaction. But moreover, we are already know, that's why we have mentioned here order of the reaction in the slow step is 2, and also molecularity is also 2. Means molecularity and order, they are not interrelated. Should remind them. Keep in your mind. I hope you understand. If they give you this kind of the reaction, order is 2, but it is not the 5. Order of the reaction is 2. Are you getting? Is it clear? Just you have to make the notes by using this one. Here molecularity seems to be a mole, but we are calculating that based on the mechanism, the reaction which is having very slow step, based on that we are writing the molecularity. And next one is the difference between the order and molecularity. I hope you remembering order and molecularity just now I discussed it. But I have given you the only order terms and important things, but I have skipped the molecularity. Intentionally I did. because it's a woman for you, we have to calculate that one. We will remove the definitions. First one, if they given any of the difference, if you told you to write the difference between order and molecularity, must and should first you have to do is, you have to make the two columns. You are not supposed to write order in the one line and molecularity in the below line. No, it's a wrong thing. Whenever they ask, you have to make the two separate columns and you have to begin to compare. Initially, for any of the differentiation, first you have to write the definition itself, order, the definition of order and the definition of molecular. So first one, the order, it is a sum of power of the concentration in the rate expression law. I told you rate is equal to dr by dt. In that we are writing the is the product of concentration raised by some experimentally determined value. Those experimentally determined values, sum we are calling that as order of the reaction. Whereas molecularity, it is the sum of number of moles of reactant is called as molecularity. And second term is order is corresponds to a overall reaction. It is considered as the overall reaction is taken to calculate the order. Whereas it is elementary step. Elementary step, why? Because in an overall reaction we are considering if the molecularity of the reaction is larger, it's more than 3, at that time we are not considering the overall reaction, we are considering only the slowest step. That slowest step is considered as single elementary reaction. Here it is corresponds to an overall reaction, whereas molecularity is corresponds to a single elementary reaction. Third one, it is experimentally determined value. Why? Because order is calculated theoretically, but unless and until we don't know the law expression, rate of law expression, it's not possible to write the order. What is the order? Therefore, it is an experimental value, and molecularity is a theoretical value. By looking the number of, just looking the reaction, it is possible to write the molecularity, means number of moles of reactant is called as molecularity. And fourth one is, it can have the fractional value or whole number or zero value. So why? Because the power of the concentration of reactant 1 by 2 or 3 by 2, 4 by 2, or it may be a negative values. But molecularity is always a whole number, means 1 mole, 2 mole, 3 mole, 4 mole, like that we are taking. But we are not taking 1 by 2, 3 by 2 moles, no, never. Therefore, molecularity is always a whole number. It is a whole number. Fifth one is, it is variable with the conditions such as pressure, temperature and concentration. Means as the temperature, pressure, concentration of the reactant varies, order of the reaction is varies, whereas molecularity is invariable. It's not a variable, it is a constant. If the concentration, pressure and temperature are varied, means molecularity is never going to be varied. Means it is independent of these conditions. Means it is an invariable. I hope you are able to find the difference between order and molecularity. Here, these are the few problems. In a chemical reaction, 2A plus B, it gives C plus 4D. The rate expression is, rate is equal to K into square bracket of, means concentration of reactant A, concentration of reactant B. The P is having the power 1 by 2 and the concentration of A is having the power, nothing is here, means it is understood that 1 will be there. So the power of A is 1 and power of B is 1 by 2. What is the order of reaction? I hope you remember it in the last previous class when I have given the same kind of the problems. If they give A and B, instead of that one, they may give any of the reaction. Based on this rate expression, it is possible to write order of the reaction by observing the power of concentration of the reactant. Here the power of A is 1, power of B is 1 by 2. So based on that, you can make it as a sum of order. Order of the reaction is nothing but it is the sum of power of the concentration of the reactant. I hope you still remember it. If not, means it is your, take it as a homework, you have to do that one problem because it is very easy one. Solution. I am lefting that one because you are familiar with and you have to do this one. And second one is the conversion of molecule from X to B. X is the reactant, Y is the product. X to B follows second order kinetics. Second order reaction is the second order kinetics. On what basis we are writing the order of the reaction? Means if the power is 2, then we are calling that as second order kinetics. If concentration of X is increased, if the concentration of X is increased to 1/3, to 3 times. If the concentration of X is increased to 3 times, how will it affect the rate of formation of Y? X is a reactant, Y is a product. If X is a reactant, if the X is increased to 3 times, then what will be the effect of rate? Means how the rate of the reaction is varies, whether it is increases or decreases. Just look at this one. Initially, rate is given as R1. R1 is equal to K into concentration of reactant. Here reactant is X. Therefore, X, it follows a second order reaction. Therefore, I have written the power of the concentration of reactant is 2, X square. This indicates that order of the reaction is 2. And when we increase the concentration of Px by 3 times, at that time rate of the reaction is changes. The changed rate of the reaction from R1 to it is R2. Therefore, R2 is equal to K as it is constant. Here we have changed the concentration of X. X is increased to 3 times. Therefore, instead of X, I have written as 3X. And 2 remains as it is because it is a second order reaction. 3X to the power 2. What will changes? 3X square means 3 square is converted as 3 3 is 9 and X becomes X square. So before we move to that one, we are going to divide R2 and R1. Therefore, just consider R2 divided by R1. The R2 is nothing but X, Rx the square divided by K X square. So here K cancels each other and X square, here also X square they will cancel mutually, and 3 square 3 3 sides 9. Therefore, remaining is R2 by R1 is equal to 9 by 1. Therefore, R2, that R1 comes here right side beside the 9. Therefore, R2 is equal to 9 R1. Means initially the rate of the reaction is K. Then after R2, by increasing the concentration of reactant 3 times, then the rate of the reaction is increases by 9 times of its initial rate of the reaction. Therefore, we are saying that hence the rate of the reaction is increased 9 times from the initial rate of the expression. So this is the second one. Next we will move to the third problem. By by using rate law, how rate of the reaction 2NO plus O2, which gives 2NO2, will change if the volume of the reaction vessel, just look here, we are showing that volume of the vessel is reduced but not the reaction. Volume of the reaction vessel is reduced to 1/3 of its volume, 1/3 of its value, if the rate expression is rate is equal to K square bracket of NO to the power 2 and O2 to the power 1. Look here, first you should analyze the problem. They have given the reaction and they have given the rate expression. Based on rate expression, it is possible to write the order of the reaction. But what they asked is, show that using the rate expression, how the rate of the reaction is changes. Rate of the reaction means in the comparing to the previous problem, how the rate, whether if the initial volume 2 and secondary volume is reduced to 1/3 of the volume. Can you see here? They are not reducing the concentration of the reactant, they are reducing the volume of the reactions. So here, volume of the vessel used. One thing I would like to tell you, Just think here, it is a container containing some amount of the quantity, that is concentration of the reactant. When we reduce the volume of the reactant containing container and the content which is present in the reactant, we are calling that as reactant. The how many reactants are there, that is called as concentration. Concentration, some amount of concentration will be there in a container. When we reduce the container, then the concentration of the, that is reactant, is increases. Why? Because comparing to the volume, if the volume is reduced, means obviously the container is, which is the containing the substance, that is concentration, it seems to be a more. Therefore, when the volume of the reaction of vessel is reduced, volume of the vessels is reduced, it means concentration of the reactant is increased. You should remember the theory. When volume of the reaction, actually they are not reducing the volume of the reactant, they are reducing the volume of the reaction vessel. The reaction where it is placed, the vessel they are reducing. Think that it is a vessel, they are reducing the space of this vessel. When the vessel size is reduced, automatically the concentration of the reactant is increases. Therefore, at that condition, what happens to the rate of expression? Initially rate is K into NO square and O to the power 1. We will see the solution. When volume is reduced to 1/3 of its value, initially the given data is the volume is reduced to 1/3 of its value, then the concentration of each reactant is increased by 3 times. I said you just now. Volume is reduced means how much volume it is reduced, that much of concentration is increases. That's why you have to take that. If the volume is reduced, it means concentration is increased. If the volume of the container is increased, it means concentration of the reactant is reduced. Are you getting my point? So based on that, we will write the mathematical expression. Here, rate is equal to K. Here I have written 3. Why? Means we are taking initially the concentration of reactant is 1. They are not given actually. Instead of NO and O2, I have taken assuming that the concentration of NO is 1. You just take it as 1. Here we are assuming that the concentration of NO and O2 as 1. Therefore, if concentration of 1 is increased by 3 times nothing but, therefore 1 we are taking 1 into 3 times nothing but 3. Therefore, NO I have taken as 3 and O2 I have taken as 3. Therefore, 3 square is equal to 9. 9 3 is 27K. Therefore, rate of the reaction is increased by 27 times. Rate of the reaction is initially K. When we increased it by 3 times, means concentration is only increased 3 times. It means they have given the concentration increases 3 times. When? Because the volume of the container is reduced to 1/3. If volume reduced by 1/3 time, then the concentration is increased by 3 times. You should remember that if the volume reduced means concentration is increases. So this is third expression, third problem. Similarly, the fourth one, the rate equation for the reaction of NO with ozone O3 is rate is equal to K into NO and O3. You are not supposed to write it in a separate line. Try to write this in a single line. Rate is equal to K into NO and O3. If the rate is nothing but they have given the value of rate. Rate is equal to 6.6 into 10 raised to minus 5 mole per second. When the concentration of NO is 1 into 10 raised to minus 6 molar, and the concentration of O3 is 3 into 10 raised to minus 6 molar. Calculate the rate expression. Rate expression is nothing but K you have to calculate. But we know that the rate is equal to K into product of concentration of reactant NO and O3. They have given the rate value. They told you to calculate the rate constant. NO and O3 they have given. Therefore, by rearranging this expression, K is equal to K as it is. We are sending this NO and O3 to the left side. Rate divided by NO and O3. By substituting the values, rate value is 6.6 into 10 raised to minus 5 and NO value is 1 into 10 raised to minus 6 and ozone value is 3 into 10 raised to minus 6. By the mathematical calculation, by using the calculator, the value of K is 2.20 into 10 raised to 7 per mole per second. The value assigned is per mole per second because here m cancels and remaining m, if it moves to the numerator, it becomes minus 1 and already second is a per second. Are you getting this one? I hope there is no difficulty in solving the problems because it is a easy one. This is quite a normal problem. The still next upcoming problems are important in this chapter. So I will tell you the which one is more important. You are not supposed to neglect this one. Keep in your mind, practice this one, and based on this, we will come in the end of this session. This is a homework, and I have been giving you some of the assignment or homework question. These homework are considered the assignment question, so you are not supposed to forget this one. You have to take this as an assignment. At the end, I'm going to check these question answers as an assignment. Okay. So tomorrow we will meet in the next video. If you are having any doubts, you can text me in my WhatsApp. Okay. Bye.